I don't know about you, but the first time when I took a look at the M code in the advanced editor of Power Query, I really got scared. And I said it aloud, what are these worms floating around? In this video, I'm going to talk about the construct and the fundamentals of understanding the M language in Power Query so that once you take a look at the advanced editor, it looks a lot less like worms and you understand what's going on. Let's start. Alright, this might be a little longer than the usual videos that we do. And in order for me to make this video a lot more structured and easy for you to understand, I'm going to divide this entire video into three main buckets or three parts. Part number one, we're going to take a look at the syntactical requirements that you have to adhere to when you're writing M code. What happens in the advanced editor? Part number two, we'll actually take a look at a query that I write in the advanced editor and how does the syntactical requirements play a very important role. So I'll maybe write an example query. And part number three is going to be different objects which are there in the M language and how could you probably use them. Objects like tables, lists, records, things like that. No further ado, let's start. All right, I'm in Excel Power Query right here. I've done a few transformations on the sample data that I have. And I'm already assuming that you have the preliminary understanding of how the query works, how do you apply a bunch of transformations. This is not, however, our playing ground. We're going to take a look at the advanced editor and take a look at a few syntactical requirements. Let's just start with the first one. If I just open up the advanced editor in the view tab, I'm going to see that this particular query right here has got three steps, and those three steps are also named right here: source, filtered rows, and remove columns. Now, the first understanding that you need to build is that every single step is a variable of its own, right? So take a look at this particular source step. In the source step, we are actually fetching the data from the current Excel file and a bunch of things around that. We're not really concerned as to what exactly are we doing right here, but we're just concerned with this particular step, source step. Now, once the table from Excel has been loaded, this particular step contains the table. And if you take a look at this particular step, this step actually goes as a feeder function to the next step, which is nothing but filtered rows. So whatever comes from the source, there is a filter function applied in Power Query through table.selectRows, and this becomes a feeder. And whatever is the output of this particular step, which is filtered rows, this becomes a feeder to the next step right here. So every single step that you create could possibly be holding any value. It could hold a number, it could hold a table, it could hold any function, it could hold any value. And that is nothing but a variable that you can actually also allocate to other steps, and you can call these steps. The names of the steps that you write should not ideally contain spaces, but if you decide that you would want to write a space between the name of the step, then you'll have to put quotation marks and prefix that with a hash symbol. Take a look, source did not really have any space in the name because it was just a single word, so it's written in the usual way. But filtered rows has got a space in between, therefore we had to provide a quotation mark and also prefix the hash symbol at the start of this particular step name. All right, point number two, really important. This is also a place where you will tend to make mistakes if you decide to write the M queries right from scratch in the advanced editor. Please take a look. So if you take a look at the advanced editor, every single step is going to have a comma in the end to close that particular step, but not the last one. So take a look. The first step right here has a comma in the end. The second step right here also has a comma in the end, but the third step, which is the last step of the query, because there is no further step after that, does not have the comma in the end, and therefore it is the last step. So make sure that when you're writing the query and if you're rejuggling the query, the last step doesn't contain the comma, but every single step does contain the comma. Point number three, the let and the in keyword are the two key phrases that let you define the steps in between. In case you have worked with DAX, in DAX we have the var keyword and the return keyword, which let you define different steps or different variables in between. Just like that, in Power Query, the two keywords are let to begin declaring the variables or the steps, and you would close that with the in statement. Now take a look. Because we wrote the let function right here, we are able to declare three steps, which is source, filtered rows, and remove columns. And as soon as we write the in keyword, that means we are trying to close the loop of declaring any more steps any further. And then after that, we can just go here and call the step that we would want as an output. So take a look. We did three different variables right here, and our last step was remove columns. This is where we closed the variable declaration or the steps any further, and we are calling this particular step as an output right here after the in statement. So this works very similar to the var statement and return statement in DAX, but here in Power Query we have the let and the in keywords, which are fundamental to define variables or steps in between. Point number 4, the steps that you create in Power Query may or may not follow a logical or coherent order. What do I mean by that? Please take a look. Right now we have a source step. The source actually feeds to the next step, and the next step is filtered rows, which actually feeds to the next step right here, and the remove columns, which is actually the output. So now if you take a look at this particular query, our query is actually flowing into a certain order. The first step goes to the next goes to the next, and then we retrieve the output. But that's not a mandate for the query to work. I can also juggle these steps and put them in a jumbled order, and the query will actually still work. So if you just go ahead and maybe put a comma, because that's a requirement, towards the end we need to have a comma. In the second step, we'll also need to have a comma, but in the third step, we may not have a comma. I'm just going to get rid of the comma. And you can see that no syntax errors have been detected, and my query is still going to work. If I click on done, I still get the very same output that I was getting it earlier. My query still works. However, the problem is because our steps are not in the order, in the applied steps box, you're going to see nothing, but the query still gives you the correct output. Point number 5, really, really important. The evaluation or the processing of the query starts from bottom up, not top down. Please take a look. What do I mean by that? Now that we have jumbled up all the steps, you must be wondering that why and how is the query still working? Please take a look. Between the let and the in statements, we declared a bunch of steps which are all jumbled, but what we are calling as an output is nothing but removed rows right here. Now, once the query starts to see that output removed rows, the first thing it's going to do is going to start to find that where in all of these steps is removed rows, remove columns actually. So it finds the remove columns right here, and then it understands that in order for me to evaluate remove columns, I would need something like filtered rows as a step, which is going to be an input right here. Then it goes and sets to find filtered rows, which it finds it right here. Then it realizes that, hey, in order for me to evaluate this particular step, I would need the source. And then it goes and finds the source right here. So Power Query is automatically going to do the hard work of finding out which step is placed where in the query, and you don't really have to worry about it. But when you're writing the query using the user interface, the query obviously is created in a coherent order so that it becomes logical to take a look at the query and read the query. But should you want, you can also mess up the entire steps and the query is still going to work just fine. The most important point here is to understand is that the evaluation of the query, even if it is coherent, is going to start from bottom up, not top down. All right, demo time. It's time for us to now write a very simple query on our own in the advanced editor without taking the help of the user interface. So let's just start to define the query using the let and the in and all the fundamentals that we have learned, and hopefully we should be able to create a query. All right, so like I said, if you would want to define multiple steps in the query, we definitely start with the let statement. So I'm just going to call in a let statement here, and let's just start by defining a list. I will later in the video describe what exactly is a list, but for now, list is nothing but one columnar object structure. Anything that can only hold a column is nothing but a list. So let's just say that my list, and I'm not giving a space right here, therefore I'm not really including this in the inverted commas or putting a pound sign at the start. All right, so I'm just going to say that my list is going to contain 3 values. For Power Query to realize that what you're defining is a list, you have to surround that in the curly brackets. So I'm just going to start the curly bracket and maybe define 3 values. The first value is going to be A, the second value is going to be B, and the third value can be 1, right? So 2 alphabets and 1 number, and because this is a number, I have not really put that in the inverted commas. All right, pretty good. The list has been defined. Now, as soon as I want to go to the next step, I can actually put a comma in here and start to move to the next row, which is where I'll define my next step. Let's just say that in the next step, maybe I want to count the number of items which I have in the first step. But let's just actually do that in a while. I'm just going to write the in statement in here. I'm just going to call the list that I have created. Let's just take a look at what's the output that we get. If I just maybe declare one single step right here, the only mistake that I have done as of now is because this is the only step that we have, there should not be a comma in the end. I'm just going to get rid of the comma. Let's just take a look at the output. I'm going to click on done right here, and I get the list right here, which has A, B, and 1. Go back to the advanced editor and start working there. Now, what I want is I would want to count the number of items which are there in the list. Obviously, I know that the number of items are 3, but let's just let Power Query do some work. I'm going to put a comma right here, and I'm going to start to declare another variable, and I'm going to call this variable as list count. And I'm going to use a simple function called list.count. So list.count, and I have to ensure that the capitalization is there. Power Query is very case sensitive. So I'm just going to say list.count, and list.count is now asking you, hey, which list would you like to count? So I'm just going to say that, hey, I have created a list, which is nothing but my first step. I'm just going to feed that right here, which is nothing but my list, and that's pretty okay. Now, as an output, I do not really want to have the first step, which is my list, as an output. I instead want to have the count as an output. So I'm just going to call list count as an output. All right, pretty good. I'm just going to click on done. And what I now have is 2 steps, and the list count is nothing but 3 because we had 3 different values in here. Let's just add one more step to close this simple query. I'm going to jump over to the advanced editor once again. And what I'm going to do now is this. Maybe I would want to multiply the count with maybe any number, maybe 2. So I'm just going to put in comma right here because I'm declaring the third step, and I'm going to call this variable as multiply, right? And I'm going to say that, hey, I have a list count as the previous step's name, and I'm going to multiply that with number 2. All right, and as an output, what I would want is the multiply as an output. Now take a look. The first 2 steps do have a comma. The last step doesn't have a comma, and I'm just calling the last step as an output. All right, pretty good. I'm just going to click on done, and what we get is 6 as an output. And we can also now trace the 3 steps of the query that we have created. The first step is a list, the second step is the count, and the third step is nothing but the multiplication. That's how you would write a very, very simple query in the advanced editor. All right, we finally jump on to part number 3 of this video, which is understanding different object structures in Power Query. What do I mean by that? When you're working with the query and you're trying to mash up your data, trying to transform your data, you'll end up working with different objects that you have in Power Query. And what exactly are those objects? How do you gain access to those objects? How do you create those objects? We'll discuss all of that. Now, in particular, I'd like to talk about 5 different very important objects, which is nothing but tables. We'll talk about lists, we'll talk about records, we'll talk about single or scalar values, and the 5th one is we'll talk about functions. Let's start. All right, the first object structure that I'd like to speak about is nothing but a list. Very, very important and highly, highly useful. What exactly is a list? 1-minute definition. List is nothing but a simple 1-columnar data structure in Power Query. Now, don't confuse that with a 1-columnar table. Let me help you understand. Let's just say that we have a 3 columnar query. We have name, age, and score, and let me just delete 2 columns of the 3 columns right here. Age is gone, score is gone. Now that we have this particular column, which is nothing but a single column, this does not make it as a list. Although this is just a table with just 1 column, but perhaps you can add more columns to this particular table right here. In a list, once that list has been defined, you cannot have more columns. You can have rows in the list, but you cannot have more columns, right? All right, what I'd like to now talk about is that how do you define a list in case you would want to define the list manually, and how do you extract a list? Let's just take a look at how do you define a list first. Now let's just say that, for example, I need to create a list of 3 numbers, and in order for me to define the list where I'm typing the values inside Power Query, remember that list always is going to come inside the curly brackets. So if I maybe go ahead and create a new step right here, and in the new step I start the curly bracket, inside of the curly bracket I write 1, 2, 3, I now have a simple list which does not have the column header because it can just contain 1 column, and that's the only list that I have, which is 1, 2, and 3. Now remember that lists can only be defined manually when it contains a curly bracket. Now let's just talk about, in case you would want to extract a list, how do you extract a list from the data? Now what do I mean by extracting a list? Let me just give you 2 examples. Example number 1. What if I wanted to extract all the names of the students right here in a form of a list? How do I do that? Now what I can do is, as soon as you write the name of the column after the name of the table, what you will get is a list. Let me help you understand. As soon as I create a new step, the new step actually mentions the source. What is source? Source is nothing but the table which was there in the previous step right here. The entire table with the 3 columns. Now this is a table. As soon as you write the name of the column that you would want to extract from the table, you would get a list. So name of the table, square brackets, name of the column, and if you now commit to this particular function, this particular code that we have written, what you're going to get is nothing but a list. Example number 2. You can also extract a list by using a formula altogether. So let me help you understand one more example. So take a look, this particular data set has got 3 columns, and maybe I would like to extract the names of the columns in a form of a list. What is list? 1 columnar data structure. So I can just create another step right here, and I can say something like table dot column names, and I can start the bracket. Table dot column names is going to ask you, hey, you would want the names of the columns of which table? So source is nothing but the name of the table. It's actually a step which was like a variable which contained the entire previous steps table. All right, as soon as I now commit to this particular function, I'm going to get the names of the columns, but in the form of a list. And there are many ways to kind of extract the list, but I'm just telling you a few ways to extract the list using a function and using a column as an output. Object structure number 2, which is nothing but a record. Let's just first understand what exactly is a record. Then we'll talk about how do you extract a record. Then we'll talk about how do you define a record in case you want to do that manually. First things first, what exactly is a record? Record is nothing but one row of data. That's a record. So this is nothing but the first record or the first row of data, the second row of data, record again, a record, a record, a record, and a record. So we have 6 different records in this particular table, right? Which is nothing but 6 rows of data. Now, once you're taking a look at any particular record just doesn't contain the values of the data or the values of the row. It also contains the headers of that particular row. So what do I mean by that? When you're saying that this is the first record of data, it just doesn't contain James and 21 and 66. It also contains the headers. So that means names is James, age is 21, and score is 66. So remember that a record is going to come along with 2 different parts. One is going to be the value of the entire row, and second is going to be what is the header of that particular row. All right. Now, how do we extract a record from a table in case you want to extract any record? It's a very simple way to extract it. When we were extracting a column or a list, we were writing the name of the column. When we are extracting a record, we'll just write the row number, right? Simple enough. I'm just going to create a new step right here. In that particular step, you can see that we have the reference of the previous table right here, which is nothing but source. And I would want to extract any particular record. So all that I'm going to do is maybe write in the curly bracket, I'm going to write the number 2. That means go extract row number 2 of the table that I have mentioned. Now, when you take a look at this, you're obviously going to assume that row number 2 is like this. This is row number 2 because it's also marked as row number 2. But the counting in Power Query starts with 0 and not 1. So this becomes the 0th row, this becomes the first row, and this actually becomes the second row. So what you're going to get as an output of this particular function is row number 3, not really row number 2. And now if I actually press enter, you will see that we actually have got the record in a columnar fashion. Now, it doesn't really give you the record in a row-based structure. It actually gives you like a columnar structure, but that is still a row of the table. Now, like I said, the record has got 2 parts. So take a look. It not only has extracted the value, Tyler, age 27 and score 63, but it has also got the relevant column headers right here. So that's how you extract a record of any particular table. Now, let's just take a look. In case we want to define any particular record, how do you define that? What's the syntactical requirement there? I'm just going to get rid of this navigation step right here and create a new step. In this new step, we'll start writing a record manually. Remember the 2 parts that we need to have in the record. We need to have the value and the column header. So now, in case you want to define a record, you start with a square bracket, and the entire data, the name of the column and the value of the column is going to be defined within a single square bracket. So I'm going to say that the name is, let's say, Chandeep. Then I'm going to say that the, let's say, city is Dubai. And obviously this is going to be in the inverted commas because I'm writing text. So I have now created 2 different column headers. So name happens to be the column header, then the value of that column. City happens to be the column header and the value of that column. Now that's pretty okay. And now as soon as I press on OK, I get a similar structure like I got it last time, which is nothing but a columnar structure, which has got 2 parts, the name of the column and the value of the column. And this is nothing but one row of data. Alright, the third object is nothing but a single or a scalar value in Power Query. What exactly is that? Now the name suggests that a single value is nothing but one value. That's it. Nothing that complicated. It's just one value. 2, 4, 5, apple, chocolate are all just one single value, right? Now the first thing that we'll understand is that how do we extract one single value from a table or from a list? And then we'll also talk about, in case you want to define it, how do you do that? It's very simple. All right, let's just talk about this. So for now, let's just say that I'm trying to get to this particular value, which is nothing but 27. How do I get to that value? Now, if you think about it, this value is nothing but in the age column, and it's in which row? So it's actually in the 0th row, first row, and second row of data. So if I happen to write 2 inputs after the name of the table, so I will write first is nothing but age. Age is going to give me the entire list. And from that list, I actually want the second row of data, which is actually going to get me to row number 27, the value 27. Let's just do that. I'm going to click on the FX right here, and I'm just going to start to write list after the name of the table. So source is nothing but the name of the table, and after that I will write the name of the column that I would want to extract. The column that I'm looking for to extract is nothing but the age column. I press enter and I get the entire list. right here. And from this list, what do I want? I want the second row right here. So I'm just going to write in the curly brackets, I'm going to write row number 2, and I'm going to get the second value of this particular table, and which is actually going to be a single value. Note that as soon as you create a single value output in the query is also going to change. So here the query has changed to 1, 2, 3. That means the query is now giving you a single or a scalar value output. Now, it's not a mandate for you to write the query this way, so I can also get rid of this. And if I still wanted to get to 27, I can just do the reverse of the process as well. I can say that, hey, first I would like to get to row number 2, which is going to give me the record. So I got the entire record. And now from this entire record, the column that I would want to extract is nothing but the age column, and the column goes in the square bracket right here. And this is the same way, but we have kind of jumbled up the position of the row and the position of the column, and we're still getting to nothing but a scalar value. Now, how do you define it in case you want to manually define it? It's very, very simple. Let's just create a new step right here, and you just write the value. Note that whenever you're defining a single or a scalar value, any number is just going to be defined like this, which is 1000. But if you're defining a text, you have to probably write that in the inverted commas, right? So that's a text. The last one, which is nothing but functions in Power Query. What exactly are functions? Functions are like pre-built capabilities that you have in Power Query, which is like Power Query formulas that you can use to transform your objects, which is nothing but tables, lists, or records, whatever you're working with. Now, there are like 800 plus functions available in Power Query. You can take a look at all of the functions in the list or the documentation on the web. But how do you actually get the list of the functions? Let's just do some workaround functions and take a look at 1 or 2 functions in detail. And I'm going to give you a very important piece of advice when you're trying to learn functions in Power Query. Now, obviously, one way to take a look at all the functions is to go to the web and take a look at the M documentation and take a look at all the functions. But the other way to take a look at the functions is that you create a new step right here, and then you just write hash, and then you write shared. Once you actually do that, you're going to get all the functions in a form of a record, and you can click on the side of the function and you take a look at what exactly this function does. So list.range, list.remove items, these are all functions that you have in Power Query, and you can use these functions to transform or manipulate data the way that you would want. Alright, there are like 800 plus functions right here, and I can't really teach you all of them. I don't even know all of them myself. But here is a very important piece of advice that you can keep with you while you're trying to learn functions. Whenever you're trying to learn functions, it's very, very important to understand what is the input and the output of that particular function. What goes inside of that function at different arguments and what comes outside of it. It's going to be phenomenally important for you to understand. Please take a look. Now, I'll just give you an example. I'm just going to cancel out this particular step, and I'm just going to count the number of rows of this particular table that I have. How many rows are in this table? And obviously I can count that manually, but I would want some function to do that. Now I'm going to write a function right here, and I'm going to say that I would want to count the number of rows. So now I understand that there happens to be a function which is called table.rowCount. And if as soon as I start to initiate the bracket of this function, it's actually asking me that please give me a table for which you would like to count the number of rows. The very important part to understand is that the input needs to be a table. That means if you provide a list as an input, if you provide a single number as an input, it's obviously not going to work. So if I happen to write, let's say 1 right here, it's obviously going to give me an error. It's going to say that, hey, 1 is not really a table, and I cannot really execute that particular function. So you can see that 1 is not really a table. Right? If I happen to write a list in this, it's again not going to work. So I have to provide the input parameter to exactly what the function is asking me for. So I'm just going to maybe write something like source here. And I know that source happens to be a table because it was having multiple rows and multiple columns in here. I'm just going to close the bracket and press enter. And then it gives me the output as 6. Now 6 happens to be a single value output. Now I can just go ahead and multiply that with 2, and this is actually going to give me the answer as 12. Now this gives me a single value output. A single value output can be multiplied with a single number, and that's the output that I get. Once you're learning functions, it's very, very important for you to focus on what is the input of the function. Is it a table? Is it a record? Is it a list? What exactly is that? And what's going to be out of that function, so that you can start to use that output in some other places very, very creatively. All right, that's been it. I hope you found this video helpful. Although we did not really discuss any solution to any nasty Power Query problem, but these building blocks of the M language are going to help you understand that how do people write the M code in the advanced editor a whole lot better. Let me know if you have any questions around this and I'll be glad to reply. In the end, I'd like to give a big shout out about my DAX and my Power Query courses in case you're starting out with your journey with Power BI. And DAX and Power Query are far too hard for you to understand. You'd want to master the fundamentals first, and then you want to solve more challenging problems even of your own data. I'd highly recommend that you take a look at my courses. It's going to be super awesome. Thanks so much for sticking around all this while, and I will catch you guys in the next one. Cheers. Bye.